Yeah. Oh, Gally, yeah. All right, today we're going to continue with arcs and chords. So I'm on the bottom of page 803. And in a circle or congruent circles. Congruent central angles. Have congruent chords. Congruent chords. Have congruent arcs. And congruent arcs have congruent central angles. Okay, 803. So there's pictures for all that, but sometimes if you don't know what you're marking congruent first, I don't know if the pictures help. You know, the first one where it says congruent central angles. Congruent central angles. So if you got a circle or two different circles, and you've got a central angle here and another central angle over here, and if these central angles are congruent to each other, then their chords are congruent to each other, and that would be this segment right there and there. So if the central angles are congruent, then the chords are congruent. Congruent chords have congruent arcs. So these arcs would be congruent to each other. Congruent arcs have congruent central angles. So do you see how all of this works together? Does anybody not understand that or need a further explanation? Yes.
The chord.
This.
The arc.
Okay.
The arcs are. I thought that it was the heart right here.
This is the arc.
Oh, okay, so I was right. So
red is the arc. Blue is the chord. Black is the central angle. So red is the arc, blue is the chord, black is the central angle. If any one of those items, if any pair of those are congruent, then the others are congruent. Meaning, if the chords are congruent, then so are the arcs and the angles. If the angles are congruent, so are the arcs and chords. And if the arcs are congruent, so are the chords and angles. And looking at it, hopefully it just makes sense, right? That if this angle opens up so many degrees, if this angle right here opens up so many degrees, it's going to hit the circle here and here. And if that same angle opens up that same number of degrees on the other side, it's going to hit the circle here and here. And the arcs and the chords are going to be the same. And vice versa, all the way around. Okay? So if you're given a picture, turn to page 804. There's example 3 there. You're given a picture of a circle and it's got a couple of chords in it. And if you're told that these arcs are congruent and that this arc is 3x and this arc is 2x plus 27 and this is arc RS and arc TU or UT, find the measure of RS. They're equal to each other, right? And actually the information that they tell you is that chord RS is congruent to chord TU. If the chords are congruent, then the arcs are congruent, and 3x is equal to 2x plus 27. So if you subtract 2x, then x equals 27. And if x equals 27, remember that this means the measure of arc RS. So 3 times 27, 81 degrees. Okay? All right, so I'm going to the top of page 805. And I want you to get those theorems in your notes. In a circle, if a radius or diameter is perpendicular to a chord, this is perpendicular to a chord, then it bisects the chord and its arc. In a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. And in a circle, the perpendicular bisector of a chord is a radius or diameter. Got it? You got that written down? All right, so look at example 4, using radii and chords. Here's your diagram. Find B to D. Let's see, find BD. And you are given that this piece is 2 and this piece is 3. And you're also told that these are perpendicular. So didn't you just write down that if a radius is perpendicular to a chord, that it bisects the chord? All right, so isn't B to C the same as C to D?
Yes.
Okay. Do you see a right angle in this picture anywhere? All right. So let's see here. Do you see this dashed piece? Goes from the center to the edge of the circle? What's the length of that dashed piece?
5.
5, because it's the same as A to E, which goes from the center to the edge of the circle. So if this is 5, don't you have a right triangle right here?
Oh, I got it.
And that right triangle is missing a leg. So if 3 squared plus, call this piece x if you want, 3 squared plus x squared equals 5 squared, doesn't it? So 9 plus x squared equals 25. Subtract 9. X squared equals 16. And if you find the square root of each side, then x equals 4. If x equals 4, how far is it from B to D?
Oh,
No, 8.
8.
It's 8, isn't it? Because if a radius is perpendicular to a chord, then it bisects it, right? And if this piece of it is faux, then the whole piece is 8. Right? Very good. Very good. Let me see. They don't have an example of it. Let me see if I can think of the one that you'll really enjoy. Circle.
So, we're gonna enjoy this one.
I just like this question. Let's see. I think you get this. Oh, let's put it somewhere else, just to mess with your eyes. I think you've already figured out. Oh well. Find E to F. Oh wait, I made it too easy. I apologize. You got it? I don't know, is it?
I thought it was 7.
I don't know, is it?
Is it 7? Is EF 7?
Not 7.
Oh. Wow.
I don't know. I don't know what it is. I mean, I know how to figure out what it is, but I don't know what it is yet. Think of a clock. Think of an old school clock. And what do the hands on an old school clock do?
Oh, go around. We have the time by 2.
So let me times that. So is it 5? I got 21 for you.
I don't know.
Alright.
Well, look.
I mean, those are 1.
Look, when you ask yourself, what does this represent? Where does it go?
It can go anywhere.
Can it?
Yeah.
E to F is the same as E to B, isn't it?
Yeah.
It's a radius.
And ED. Oh, okay. I'm so smart.
So isn't it just 5 squared plus 7 squared equals this squared? It's just a hypotenuse. It's the hypotenuse.
Yeah, you did. You play with the eye.
Try to play with your eyes. I'm almost positive that's a quiz question.
Yeah.
And when you first look at it, because here's what I did, here's what I meant to do, and I didn't. I meant to do this. And ask you the same question, but tell you find E to F when BD equals 14. Then there's only one number on there. And to your eyes, it's like there's not enough information. But if you just go back to the fact that, when a radius is perpendicular to a chord, it bisects it. So if B to D is 14, then this piece is 7. And that the radius is the same from the center to the edge of the circle, no matter where it is in the circle. So you can redraw this if you have to, and it forms your right triangle, and you can use Pythagorean theorem.
What's squaring up with something?
So what did it end up equaling?
8.6.
8.6. Okay. Everybody got it?
Yeah.
Okay. So that's how the information related to these theorems can be presented. You just got to dig it out. All right, so your practice for today is on page 806. And what did we do? We did 3 and 4. So 15 through 18. And then over on the other page, you can do 29 to 32. And check headline for homework.